Hi everybody, this is Concept 3. So it's good to be back with you. Today we're learning something new. It's going to look very similar to something we've seen in the past, but we're going to look at it on the graph. So today we're going to do trig functions. And the first one, the most basic one, is our sine curve. So our sine curve is y equals sine x. I'll pop it up on Desmos here so you can see what that looks like. We have a graph here, and we just want to take a second to write down some things that we notice. So one thing that I might notice is that it goes through the origin. Goes through the origin. I might say from time to time that it starts there, and it goes up first, and then after it reaches a peak of at 1, it goes down. And then it goes back up, and I would say that that is like one cycle, right? So it goes up to 1, and then down to -1, and then back up to 1, and then down to -1. And we see that it does this cycle over the course of repeats over and over and over again. So that's one of the things I can see there. I see that in order for it to take one cycle, it goes from 0. And then I see that this is kind of funky. Along the x-axis is measured in pi. So instead of like 1, 2, 3, this is actually like 1/2 pi. So like pi divided by 2 is here, and then pi is here, and then 1.5 pi is here because this is 2 pi. So I see that it repeats every time it goes 2 pi. So from -2 pi, it's going to go in here to 0. That's 2 pi as well. That's what we call a period, but we'll get to that later. So what I'm going to do here is show just sort of the ways that we can transform this graph. So if I look at the next graph here, this is negative sine x. And what we see is that it still goes through the origin, still through 0, 0. But this time it sort of flips over and it goes down first, right? And so I can see, if I'm in Desmos, I can see if I put a negative in there, it just flips over. Everything that it was before is now flipped upside down. But it's the same exact pattern, right? So it goes down and then it comes back up and then it goes down again. And we see that it still makes that repeat. It starts to repeat at 2 pi. I can see that we can change something as well. If I see this 2 here, notice what happens to the graph when I put a 2 here. Right? So here was the regular one, and then I put a 2 there. Notice that it got taller. So it got taller. And what I see here is that there's a 2 in front, and now it's going up to 2. Right? It's going up to 2 and down to -2. So take a guess. What do you think is going to happen if I put a 3 here? Yeah, it's going to go up to 3 and down to -3. If I put a 6 here, it goes up to 6 and down to -6. So that is what we call amplitude. And amplitude is how high / low the graph goes. Right, so if we start at the center of the graph, we can see how high it goes. This would be 2. And then if we start at the center of the graph and we go down, we see that it goes down 2 as well. So we would say that the amplitude of this is 2. We also see that in the equation, it's the very first number. So that number is also what we call a vertical stretch. Right, so vertical stretch. That's what we want to see there. All right, if we put a negative number there, just by the way, if we put like -2, it flips over and it stretches, so it does both. So here's just the negative, and then the 2 would make it stretch out. So awesome. As we look at this, we also have something called, we can see that the change that we're making is putting a 2 inside there. So this is my regular graph, and watch what's going to happen when I put a 2 inside. It got really squished together, right? So I don't know how we want to see that, but there's more ups and downs. It's squished together. And the way that we could describe this is we could say that the period is smaller. And what that means, the period is the time it takes to travel one cycle, maybe we might say. Right, so in this case, we start at 0, we go up, down, up. But we see this time, instead of having to go, remember last time it had to go up, down, up, and it ended at 2 pi? This time it ended at just 1 pi. So we would say that the period of this function is 1 pi, because that's how long it takes to go one cycle, right? So then you might be asking, like, why is this number 2 if this is 1 pi? And we will get there in just a minute, but for right now, what you want to remember is that the time it takes to go one cycle is your period, right? So those are our sine curves. So 2 big words we learned. One is amplitude, how high does it go? And then period is how long does it take to travel one cycle. Okay. So we're going to check out our blue graph now. I'm going to see if I can make this a little bit bigger. I'm going to turn off my sine graph and check out my cosine graph. So things I might notice, it's the same as sine, sort of, except at 0, it starts at 1. So when x equals 0, y equals 1. We see that that starts right there, right? So it starts up high rather than starting in the middle. And then we see that its period, it goes down, and then it comes back up. So it goes down to -1, it goes back up to +1. And we see that that's where it starts to repeat again. So if I was going to use my vocabulary I just learned, I would say that the amplitude is 1, because it goes up 1 and down 1. And then I would say that the period is from 0 to 2 pi. So I'd say that the period is 2 pi, right? So I use the same vocabulary. If I put a negative in front, what do you think is going to happen? It's going to flip over, right? So now instead of starting at +1, it's going to start at -1, and it goes up first this time and comes back down, right? Still repeats right here. So in this case, I would still say the amplitude is 1, right? Because it's going up 1 and it's coming down 1 from the middle. And then I would say that the period of this function is still from 0 to 2 pi. So I would still say the period is 2 pi. All right, so fairly simple. That's just how we're going to talk about it. So we could say things we notice starts at y equals -1 this time. So that's where we can start. We're going to see really similar things happen. So this is our normal graph. If I put a 2 in front, right, so I'm going to change my amplitude to 2. So now my amplitude is 2 because I have to go up 2 and down 2 from the middle. And then my period, I haven't changed. So it's starting here at 2. It's going down and then back up. And I see that that's happening at 2 pi. Right, so it's still taking 2 pi. I'm glad we're using that vocabulary amplitude there. And then here we see if I change, instead of this one, I change this here, it gets really squished together. Same thing is happening, my period is changing. So from 0, this is only going to 1 pi this time. So my period is 1 pi. That's how long it takes to repeat itself. So that's the basics of the graphs. We know that this is very similar to what we've seen in the past. So we have our sine function, it's what we call a parent function. A is going to change its vertical stretch, right? So it's going to make it get taller, just like we saw with parabolas or polynomials. If we see this k over here, you guys know that moves the graph up. Moves graph up. This one here, h, moves left and right, just like normal, y'all. Nothing of this has changed from before, just with sine function now. And then b, remember b is gonna stretch it or shrink it. Shrink, stretch, and that's the period. So it's gonna shrink and stretch horizontally, we could say. So if I'm looking at these changes here, I have the cosine curve and it says +1. So I can see that the middle of my graph shifted up to 1. Usually we see it go up and down between 0 and -1, and here we see the middle of the graph is here. So we could say that this is shift up 1. And then my sine curve usually goes through 0, and now the middle of it is going through -2, which makes sense because we see the -2. So we could say this one was shifted down 2. So if I turn on my sine curve here and I just say, okay, -2, it's going to move down. If I say +2, it's going to move up. The same is true for my cosine curve. If I say -3, it moves down 3. If I say -1, it moves down 1. If I say +2, it moves up 2, right? So very similar to what we know already. All right. So I promised that I would talk a little bit about periods very fast. So the period that we look at is, the formula is that the period is 2 pi divided by b. So we've talked about this in the past, just like for a hot second, but 2 pi is what we call radians. And 2 pi radians is the same as 360 degrees. It's how long it takes to go around a circle, right? And so without getting into too much detail, we can find the period or use the period with this formula, 2 pi divided by b. So if they give you the period, or if you can see how long it takes to repeat on the graph, you put the number into this section here. So here I can see we start here, it goes down this way, and it comes up here. So I could say that the period, it says what's the period? The period is 1 pi, because it's going from 0 to pi. Right? So what I would take this, and I'm going to put it in there. Right? So I would say pi equals 2 pi divided by b. Right? I could multiply this. I could say, okay, what number do I have to put in to b? And the number that I have to put in here is the number 2, because then 2 and 2 divide out and leave me with just pi. So I know that b equals 2. So when I go to write my equation, I know that this is a cosine curve. Right? I know that's a cosine curve because it starts at +1. I know that it's a positive cosine curve because it's going to head down first. Right? And then I know that my period is 2, so I'm going to put 2x, like that. So if I have my cosine curve, oh, I already have it graphed here, but I can see that's my normal graph, and it goes from 0 to 2 pi. If I put a 2 there, it gets scrunched up, and that's exactly what we can see here. Right? If they give you the equation, you can take that b and you can pop it in right here. So we say that we would say here that the period is 2 pi divided by 3. So that means that it's going to take the graph 2 pi divided by 3 in order to repeat. So if I change this to a 3, we can see that 2 pi over 3 is how long it takes. So it goes from 0 over to 2 pi over 3. So periods can be a little funky. If you're honors, we'll work a little bit more with them. If you're on track, it's just good to know and to recognize this formula. Thanks, guys. Ask some questions. Good luck.